Hey everybody, in today's lesson we're going to be looking at non-parallel lines and transversals. Now below I'm going to go through the definitions of what each term means, but we're actually going to look at this below and we're going to list them according to the diagram that we have so you can get a true understanding. But first we're going to go through the definitions. So transversals, it's a line that intersects two or more lines. Corresponding angles are two angles that occupy the same relative position at two different intersections. Vertically opposite angles are angles created by intersecting lines that share only a vertex. Alternative interior angles are angles in opposite positions between two lines intersected by a transversal and also on alternate sides of the same transversal. Alternate exterior angles are angles in opposite positions outside two lines intersected by a transversal. And the last one we're going to look at is interior angles on the same side of the transversal. So these are two interior angles lying on the same side of the transversal cutting across two parallel lines. Now, just going through the definitions, it's hard to get a true understanding of what this means. So we're going to look at this below. So first thing we're going to look at is the corresponding angles, which is the two angles. So we're looking for two angles that occupy the same relative position at two different intersections. So the big thing that you're going to notice is that it's the same relative position. Now, at this diagram, we should talk about these different lines. T here at the top is going to represent our transversal line. So that's a line that intersects two or more lines, which we have line 1, which is going across here, and line 2, which is going across here. So our transversal always goes through at least two lines. Now we're looking for a corresponding angle, which is going to have angles that are relatively the same position. So if we think about angle 1 here, and we're looking for one that's in relatively the same position, we'd be looking at angle 5, which is in the relative same position. It's in the top right corner. So we'd have, for corresponding angles, we'd have 1 and 5 as similar angles. We'd also have 2 and 6. So we could have 2 and 6. We could also have below that 3 and 7. And last we'd have 4 and 8. The next part we want to look at is the vertically opposite angles. So these are angles created by intersecting lines that share only one vertex. So they share only one vertex and they're created by intersecting lines. So we're going to list them here beside opposite angles, and we're looking at, for example, angle 1 and angle 3. So they're vertically opposite. They're right across from each other. So we'd have 1 and 3. Another one that we would have is 2 and 4 because they're vertically opposite. Opposite of 5 would be 7. And opposite of 6 would be 8. Next thing that we're going to look at is the alternate interior angle. So the alternate interior angles are angles in opposite positions. So opposite positions between two lines intersected by a transversal. and also on alternate sides of the same transversal. So an alternate interior angle would be, for example, 3, so this angle up here, and 5. So they're on the opposite side of the transversal, and they're inside these two lines. So they're inside the lines. So we'd have 3 and 5 because they're alternate and they're opposite sides of the transversal. We would also have then 4 and get rid of the shading, 6 because they're opposite sides of each other. So we'd have 4 and 6. And alternate exterior angles is our last one that we're going to look at. So if interior was inside of those two lines on the transversal, now we're going to be looking at lines that are angles that are outside. So they're going to be either up top or below. So they're outside of the two lines. So if we're looking at angle 1, so up here, opposite would be 7. So we'd have 1 and 7, and opposite of 2 would be 8. So we'd have 2 and 8. Now there's another couple of tricks to help you find these. For corresponding angles, F is often used to help you find exactly what these would look like. Because when you start looking at this, you can see an F shape makes right here and right here. So you're going to have the top of the F being 1 and the inside of the F being 5. If you rotate this, for example, even upside down, and we went like this and this, we have the top of the F being 7 and the inside being 3, which matches up with this one here. So no matter which way you rotate that F, even if you went backwards and you did like this and like this, you'd have the top of the F and the inside of that F. So it's flipped over, reversed, but it still follows the exact same locations. So you could have F like that. You can have F backwards. You could also have F upside down, and you could have upside down and also backwards. So those would be the different formations you could find it in. And you're always going to find it on top and right inside there. Next, if we look at a shape for opposite angles, well, we know that 1 and 3 were 1. Well, they're across from each other here, and they're 2 and 4 are also opposite angles, so they make an X always. So if you look for that X, you're going to be able to find exactly where that opposite angle is. The next one we're looking for is alternate interior angles. The that this is going to make is a Z. So if we think about our angle right here, it's going to create a Z, and you're going to have an angle here and an angle here. So right there and right there. You could also have it reversed, where you go like this, down, and here, and your angle is going to be 6 and 4. So we could go backwards as well. And our last one, our alternate exterior angle, which was 1 and 7, follows the same shape, but you're doing the exterior. So when we're looking at the Z here, we're looking inside and inside. But if we're looking for our alternate exterior, we're going to be outside and outside. So interior is inside, and exterior is going to be outside. So we'd also have our shape of a Z here, and we'd have exterior and exterior angle. Now our last thing is we're going to just scroll up and add another part to this. Talking about interior angles on the same side of the transversal, we're looking for a C. Now it's going to be kind of a boxy C, but interior, so they're inside of these two lines, and they're on the same side of the transversal. So the transversal is going up and down, so they're on the same side. You could also have a reverse C, or it's kind of like an open box, where you'd have 3 and 6 are on the inside, so they're interior angles, and they're on the same side of the transversal. Now we're going to go over to the diagram on the next page, and it says to try, in the diagram below, identify the relationship between each pair of angles. So if we're looking at angle 7 and angle 8, well, let's think about what shape this is creating for us. So we have our angle here going up like this and going up across. Well, it looks like it's making a Z for us. So we're looking at our alternate interior angle. So we would slide back down and we would label this alternate interior angle. B asks us for angle 2 and angle 7. So we have angle 2 up here and we have angle 7 right here. So if we look at this, this is making our upside down and reverse F shape. So if we look at what that's going to be, well, that's going to be our corresponding angle. So for B, it's going to be our corresponding angle. B is going to ask us for angles 1 and angle 6. So I'm going to erase this, and we have angle 1 and angle 6. Now, this is our transversal, and we have line 1 and line 2. When we're looking at this, this is going to be one we did not talk about on the next page. So it's important to pay attention to this one specifically here because it's not one that we listed on the other page. What this angle is going to be is called the exterior angle on the same side of the transversal. Now, exterior meaning it's outside of the two lines that we have. So it's outside of line 1 and line 2, and it's on the same side of the transversal because the transversal runs up and down and it's all on that right side. So it's an exterior angle on the same side of the transversal. This one's essentially describing exactly what it is. Exterior angles, so both outside of the two lines, and on the same side, so both on the right side of the transversal. Now we're looking at angle 5 and 7. So we have 5 here, and we have 7 here. So if we think about the shape that it's making, if we look back to our previous page and scrolling up, it's going to create the shape just like this, which is going to be interior angles on the same side of the transversal. Now, that should make sense because it's inside, so it's an interior angle, so it's inside the two lines, and it's on the same side of the transversal because they're both on that left side of the transversal. So we'll write down interior angles on the same side of the transversal. Now we're going to go over to part A here where it says transversals versus non-transversals. So look at the diagram below. Name the transversal and why. Look back to the previous page with the definitions of what a transversal is. A transversal is a line that intersects two or more lines. So we're trying to find a line that is going to intersect two or more lines. Now I'm going to start off with A and E. So A and E, this line right here, up and down, is going to be intersecting, and it's going to intersect AB, and it's also going to intersect E and D. So intersects A, B, and E and D. The next line we're going to talk about intersects with the same lines, but it's on the opposite side. So we're going to talk about B and D. So B and D intersects with AB and ED. Another line that we could talk about that as a transversal would be AB. So this line that goes across here, well, it's intersecting with this line that's coming up and down and this line that's coming up and down. So AB would intersect with BD, D, and AE, which also means that ED would also be another one. Write down ED intersects with BD and AE. Now, we could also consider that CB, so this line right here, as well is intersecting with AE and DB. So CB is intersecting with BD and AE. So you should be getting the idea now that any line that comes into contact with two other lines is going to be a transversal. Now that means that this could go on and on in this diagram, so we're just going to leave it as more for right now. But if you're ever asked to list them, it'll ask you to list a certain amount of transversals. For the diagram below, in the diagram, T is the transversal that intersects with line 1 and line 2. Name another pair of lines and their transversals. We have T listed as our transversal, but really this could all switch. We could really have L1 intersecting with T and L2, and we could have L2 intersecting with T and L. This goes to show that it really depends on how the lines are listed in what determines is the transversal. So that's going to complete it for the lesson today. If you have any questions, please send me a message in Teams or ask me in class.